What if everything we think we know about the dawn of technology is wrong? Picture this: long before silicon chips or steam engines, before even the pyramids scraped the sky, civilizations we've barely begun to understand might have harnessed powers that still baffle us today. The universe is old, impossibly old, and hidden in its ancient shadows could lie secrets that rewrite history itself. We're not talking about simple tools or forgotten inventions. We're talking about technologies so advanced, so otherworldly, that they defy the timelines scribbled in our textbooks. Who or what could have created them? And what happened to these cosmic marvels? This isn't just speculation. Across the globe, buried in crumbling ruins and encoded in myths older than written language, there are whispers of something extraordinary. Stories of gods wielding weapons that could level mountains, devices that bent time and space, and knowledge so precise it aligned entire cities with the stars. Were these just legends, or could they be fragments of truth, echoes of the universe's first true technologies? Scientists, historians, and even astronauts have dared to ask these questions, peeling back layers of mystery to uncover clues that don't fit neatly into our understanding of the past. Today, we're diving deep into 30 of the most compelling theories about these lost innovations, ideas that stretch from the edges of astrophysics to the heart of ancient archaeology. Some will challenge everything you thought you knew. Others might send chills down your spine, because if even one of these theories is correct, it means our ancestors weren't just primitive survivors. They might have been pioneers of a forgotten age, standing on the shoulders of giants we can't yet see. So buckle up, we're about to journey across time, beyond the limits of conventional science and into a past far stranger and far more brilliant than you've ever imagined. Imagine a universe so young that stars hadn't yet ignited, where the building blocks of reality swirled in an endless cosmic dance. Now picture something even more astonishing: tiny machines, no larger than atoms, silently assembling the very fabric of existence. This is the heart of the primordial nanotech hypothesis, a theory so radical it blurs the line between nature and technology. At its core, this idea suggests that the first inventions weren't crafted by hands or minds, but by the universe itself. Self-replicating nanobots or molecular machines could have emerged spontaneously in the extreme conditions of the early cosmos. Think of them as cosmic bricklayers working on scales we can barely comprehend, shaping galaxies, stars, and even the chemistry of life. It sounds like science fiction, but look closely at nature's patterns. The branching veins of leaves, the spiral arms of galaxies, even the structure of our own lungs. These aren't random, they're fractal, repeating designs that hint at something orchestrated. Ancient texts and myths might hold clues. The Hindu concept of the Brahmastra, a weapon said to reduce matter to its smallest particles, or the Norse Gungnir, a spear that never missed its mark. Could these be distorted memories of technologies far beyond their time? Even modern astrophysics stumbles upon anomalies, strange metallic signatures in primordial gas clouds, or unexplained energy fluctuations in deep space that behave less like natural phenomena and more like machinery. What if the universe didn't just evolve, it was built? And what if the architects left their tools behind, hidden in plain sight? The implications are staggering. It would mean technology isn't something we invented, it's something we inherited. A relic of a process so ancient, so fundamental, that it's woven into the fabric of reality itself. And if that's true, the next question is unavoidable. Who or what were the original engineers? Now consider this: what if the universe wasn't just built but programmed? At the smallest scales of reality, where space and time churn like a bubbling sea, lies a phenomenon called quantum foam. This isn't just empty void, it's a seething ocean of particles flickering in and out of existence, a cosmic static at the foundation of everything. But what if this chaos wasn't random? What if it was the universe's original operating system? Enter the theory of quantum foam computing. It suggests that the very fabric of spacetime might have functioned as a vast, natural supercomputer in the early cosmos. Think of it like cosmic code running on the universe's hardware, each fluctuation in the foam acting like a binary switch, processing information on scales we're only beginning to fathom. This could explain one of physics' greatest mysteries: why the fundamental constants of nature, the speed of light, the strength of gravity, are so exquisitely fine-tuned for life to exist. Were they adjusted? The evidence is subtle but spine-tingling. Anomalies in the cosmic microwave background, the afterglow of the Big Bang, show strange patterns that defy conventional explanations. Some regions appear oddly pixelated, as if the universe's rendering distance had glitches. Could these be artifacts of an ancient computational process? Even more striking, certain particle behaviors in quantum mechanics, like entanglement, where particles instantly influence each other across vast distances, mirror the logic gates of a quantum computer. Ancient traditions might have glimpsed this truth. The Kabbalistic concept of tzimtzum, where the divine contracted to make space for creation, echoes eerily with the idea of spacetime as a programmable medium. And modern experiments with quantum teleportation, where information jumps between particles without crossing the space between them, hint at a universe built on protocols we're only starting to decode. If this theory holds, it rewrites the origins of technology itself. The first computer wasn't built in a lab, it was the cosmos, humming with silent calculations that set the rules for reality. And that raises a haunting possibility. If the universe can compute, could it also? Remember, are the laws of physics not just equations, but lines of code from a civilization so advanced they engineered existence itself? The answer might be hiding in the static between the stars. Dark matter, the universe's most elusive enigma, doesn't just linger in the shadows, it shapes everything. Invisible, undetectable, yet holding galaxies together with its gravitational grip. It's the hidden skeleton of reality. But what if this skeleton wasn't just random cosmic debris? What if the way dark matter clusters and weaves through space isn't accidental but architectural? Some scientists now suspect the distribution of dark matter is too precise, too eerily organized to be purely natural. Take the Bullet Cluster, where two galaxies collided, and their dark matter, detectable only by its gravitational lensing effect, did something inexplicable. Instead of scattering chaotically, it formed near-perfect arcs, as if guided by an unseen hand. Even more baffling are the dark matter filaments, connecting galaxy clusters like cosmic highways, structures so vast they defy probability, spanning millions of light-years with geometrical precision. Ancient cultures might have sensed this hidden order. The Dogon people of Mali, for instance, described the universe as a spider's web, mirroring modern astrophysics mapping of the cosmic web. The Maya spoke of black roads in the sky, while Hindu texts referenced invisible threads binding creation. Coincidence, or could these be fragmented memories of a truth once known? Then there's the too big to fail problem. Supercomputer simulations predict small, dense clumps of dark matter should orbit galaxies like ours, but when astronomers look, those clumps are missing, as if someone cleaned them up. It's as though the dark matter in our cosmic neighborhood was deliberately arranged, leaving no loose ends. The boldest theory: dark matter isn't just a substance. It's infrastructure, engineered scaffolding left by civilizations so advanced they didn't build planets or stars. They shaped the gravitational fabric of the universe itself. Maybe they're long gone, or perhaps they're still out there, hidden in the darkness between the threads, watching as we stumble toward the truth. One thing's certain: if dark matter was designed, then whoever, or whatever, did it didn't just play with technology. They played with the laws of physics, flickering across the void like celestial neon signs, Vast tendrils of superheated plasma stretch between galaxies, threads of charged gas so immense they could wrap around our Milky Way 1,000 times. These aren't just cosmic decorations, they're the bones of the universe, sculpting star nurseries and funneling matter across billions of light years. But what if their eerie symmetry isn't just a quirk of physics? What if someone or something once harnessed these filaments like cosmic lightning rods, bending them to their will? This is the wild frontier of plasma cosmology engineering. At its core lies a tantalizing observation. The way plasma behaves in laboratory experiments mirrors the structure of the universe itself. When scientists zap gas with electricity in a vacuum chamber, intricate webs of glowing filaments form patterns shockingly similar to the cosmic web, that labyrinth of galaxy clusters and plasma threads spanning the observable universe. Now imagine a civilization so advanced they didn't just observe these forces, they commanded them. Here's where it gets spine-chilling. Certain ancient texts describe rivers of fire in the sky or serpents of light weaving the heavens. The Aboriginal peoples of Australia spoke of the rainbow serpent shaping the land, while Norse myths told of the world tree Yggdrasil, its branches crackling with unseen energies. Could these be garbled memories of plasma manipulation on a galactic scale? Modern astrophysics adds fuel to the fire. Regions like the Hercules Corona Borealis Great Wall, a structure so enormous it breaks theoretical size limits for cosmic formations, show plasma arranged in near geometric perfection, as if someone deliberately stretched it into place. Then there's the star-making problem. Normally, gravity alone takes hundreds of millions of years to birth stars from gas clouds, yet pockets of the early universe blazed with fully formed stars impossibly fast. Some theorists speculate that advanced beings could have used plasma filaments like cosmic particle accelerators, zapping gas clouds with precisely aimed currents to trigger rapid stellar ignition. Picture it, entire solar systems switched on like light bulbs, their births accelerated by technologies we're only beginning to dream of. The smoking gun might lie in the dark currents, recently detected streaming along plasma threads, flows of charged particles moving far faster than standard models predict. It's as if the universe's wiring still carries traces of an old, unfathomable signal. If true, this wouldn't just rewrite history, it would shatter our understanding of what's possible. Because engineering stars isn't just playing with technology, it's playing God, and the universe, it seems, might still bear the fingerprints of those who dared. Black holes aren't just cosmic vacuum cleaners, they might be the universe's oldest hard drives. Picture this, a civilization so advanced they didn't just use technology, they bent the fabric of spacetime itself to store information. At the heart of this theory lies a mind-bending idea that primordial black holes, those tiny, dense remnants of the Big Bang, weren't natural accidents. They were engineered as quantum vaults, their event horizons etched with data in ways we're only beginning to decode. The clues start with the holographic principle, a radical notion in physics suggesting all the information in a three-dimensional space can be encoded on a two-dimensional surface like a cosmic DVD. Black holes take this further. When matter falls into one, it doesn't just vanish. According to quantum mechanics, the information it carries gets imprinted on the event horizon in vanishingly small bits called Planck-scale pixels. Now imagine a civilization that mastered this process, deliberately creating micro-black holes to serve as indestructible archives. These wouldn't be the monstrous voids we imagine today. They'd be microscopic, no larger than an atom, yet capable of storing libraries worth of data in a space smaller than a grain of sand. Here's where it gets eerie. Modern observations of Hawking radiation, the faint glow black holes emit as they evaporate, show bizarre anomalies. Some emissions carry patterns that resemble noise, but not random noise. It's structured, almost rhythmic, like interference on a radio tuned between stations. Could this be the faint echo of encoded data leaking out after billions of years? Ancient myths might hint at this too. The Egyptian god Thoth was said to have hidden wisdom in black stones that drank light, while Hindu texts describe Kala Chakra, a wheel of time that swallowed knowledge only to spit it back out transformed. The most startling implication: if information can survive inside black holes, then the universe's first technologies might still be intact, locked away in these dark vaults. We could be living in a cosmos littered with time capsules from a civilization that cracked the code of reality itself. A civilization that didn't just leave behind artifacts, but wrote their secrets into the fabric of spacetime. And if we ever learn to read that code, we might not just uncover the past, we might unlock the future. Imagine the universe as a vast cosmic loom, and woven into its very fabric are threads so thin they're nearly invisible, yet so indestructible they could outlast stars themselves. These aren't metaphors, they're cosmic strings, hypothetical cracks in spacetime theorized by physicists, remnants of the universe's violent birth when reality itself cooled unevenly, leaving behind defects in the cosmic tapestry. But what if these weren't accidents? What if they were deliberately forged, the universe's first fiber optic cables, engineered to transmit information across impossible distances? At their core, cosmic strings are thought to be unimaginably dense. One just a mile long would weigh more than our entire planet, yet they'd be thinner than an atom, vibrating at nearly the speed of light. Picture them as ultra-durable wires stretched between galaxies, humming with encoded data. A civilization mastering their manipulation could have used them to create an interstellar communication network immune to cosmic interference, blackouts, or decay. Unlike radio signals that degrade over light years, messages sent through cosmic strings would arrive instantaneously, riding the very fabric of spacetime itself. Recent gravitational wave detections add fuel to the fire. Scientists picking up unexplained ripples in spacetime have noted peculiar patterns, some too rhythmic to be random, almost like pulses. Could these be faint echoes of ancient transmissions, faint tremors from strings plucked by long-vanished engineers? Even stranger, certain signals appear to cluster near voids, vast empty regions of space where conventional physics predicts few cosmic events. It's as if something or someone strung these voids like beads on a necklace, turning the cosmos's emptiest places into relay stations. Ancient myths whisper of similar ideas. The Maori spoke of Aho, the invisible threads binding the heavens, while Tibetan Buddhist texts describe threads of light connecting sacred mountains across dimensions. Even modern quantum entanglement, where particles mirror each other's states instantly across any distance, mirrors the logic of a universe hardwired for communication. The implications are staggering. If cosmic strings were tools, not flukes, then the universe might still be crisscrossed with their remnants, a shadow internet humming with lost knowledge. Decoding their vibrations could unveil messages older than Earth itself, waiting in the space-time cracks for someone to listen. And if we ever learn to read these strings, we might not just uncover history. We might find it still transmitting. The universe exploded into existence in a trillionth of a second, expanding faster than light itself during the mysterious inflationary epoch. But what if that sudden stretching of space-time wasn't just a random cosmic hiccup? What if it was precision engineering on the grandest scale imaginable? The theory of inflation field manipulation suggests the early universe's hyper-expansion wasn't an accident. It was a carefully calibrated process, fine-tuned by technologies beyond our comprehension. The smoking gun might lie in the cosmic microwave background, the faint afterglow of the Big Bang that paints the sky in microwave static. This ancient light shouldn't be perfectly uniform. Yet when scientists mapped it, they found anomalies so peculiar they've been called cosmic bruises, strange cold spots where temperatures dip unexpectedly. Curious alignments of hot and cold regions forming geometric patterns that defy statistical probability. Most unsettling of all, a colossal axis of evil, an unexplained directional asymmetry that makes one hemisphere of the universe slightly hotter than the other. It's as if someone adjusted the universe's thermostat unevenly. Could these irregularities be the fingerprints of intentional field manipulation? Imagine a civilization so advanced they didn't just observe cosmic inflation, they controlled it. Using physics we haven't yet discovered, they might have tweaked the inflationary field like a dimmer switch, stretching spacetime in specific directions to sculpt the universe's large-scale structure. The result, galaxy clusters aligned in vast, sweeping arcs not randomly scattered, as if space itself had been combed into shape during those first frantic moments. Ancient creation myths add eerie context. The Babylonian Enuma Elish describes primordial waters being measured and marked before the heavens formed, while Aboriginal stories speak of the Dreamtime's songlines that charted the land before it physically existed. Modern quantum field theory offers a startling parallel, the idea that vacuum fluctuations, tiny energy pops in empty space, might be programmable. If true, the universe's expansion could have been scripted like code, with intentional imperfections left as signatures. The most tantalizing clue comes from simulations. When physicists model cosmic inflation with artificial kicks of extra energy in certain regions, the resulting SIMBI patterns resemble the anomalies we actually observe. It's not proof, but it's a whisper that our universe's birth might have had assistance. If that's true, then whoever or whatever orchestrated inflation didn't just witness creation. They designed it, and the blueprint might still be visible, etched into the oldest light in existence. Neutrinos are the universe's ultimate ghost particles, so elusive they pass through entire planets like they're not even there. 1 trillion neutrinos from the sun stream through your body every second, leaving no trace. Yet hidden within this silent storm could lie the oldest message in existence, encoded by forces we can scarcely imagine. The theory of neutrino programming hinges on a baffling quirk of physics, neutrino oscillation. These particles shapeshift as they travel, morphing between three distinct flavors, electron, muon, and tau, in a rhythmic dance that defies classical logic. Ordinarily, this might seem random, but the patterns aren't chaotic. They follow precise mathematical relationships, almost as if the oscillations were programmed. Imagine a civilization harnessing this phenomenon, imprinting data onto neutrinos by deliberately altering their oscillation sequences. A single neutrino could carry information in its transformation rate, like Morse code written in quantum fluctuations. Evidence for this wild idea comes from deep underground. Detectors like Super Kamiok and in Japan have recorded neutrino oscillations with peculiar anomalies. Certain flavors appear more often than predicted, while others vanish entirely. Even stranger, some neutrino beams arriving from distant supernova show synchronization, as if their oscillations were orchestrated to match. Astrophysicists debate whether these are statistical flukes or signs of something deeper. But if it's the latter, we might be detecting fragments of an ancient signal, a broadcast so old it predates Earth itself. Ancient cultures might have sensed this hidden communication. The Dogon tribe, renowned for their inexplicable knowledge of Sirius's invisible companion star, described tiny spirits carrying wisdom between the stars, a striking parallel to neutrinos' imperceptible flow. Hindu texts speak of Vayu, the wind god who carries messages through stone and flesh alike. Even modern quantum encryption experiments, where information is embedded in particle states, echo the potential of neutrino programming on a cosmic scale. The implications are staggering. If neutrinos were engineered as information carriers, the entire universe could be filled with their whispers, a background hum of data older than starlight. Decoding it would require more than technology. It would demand rethinking reality itself, because the universe's first Wi-Fi might not use radio waves. But particles so stealthy, they've been hiding in plain sight for 13 billion years. Why is there something rather than nothing? At the universe's birth, matter and antimatter should have cancelled each other out in a burst of pure energy, leaving behind nothing but empty silence. Yet here we are, in a cosmos flooded with galaxies, planets, and life. This isn't just luck. The fact that matter outnumbers antimatter by even a fraction is a statistical impossibility unless something tilted the scales. Physicists call this the baryon asymmetry problem. But what if it wasn't a problem at all? What if this imbalance was the universe's first and most crucial engineering project? The numbers don't add up naturally. For every billion antimatter particles in the early cosmos, there should have been 1,000,000,001 matter particles to explain what we see today. That razor-thin margin, just one extra particle per billion, defies every known law of symmetry. Recent experiments smashing particles at CERN reveal something even stranger: the degree of CP violation. The phenomenon that allows matter to dominate is fine-tuned to an almost impossible precision. Like a cosmic dial turned to exactly the right setting to make stars and us possible. Now imagine ancient architects didn't leave this to chance. Picture them manipulating quantum fields in the universe's first moments, tweaking the behavior of quarks and leptons to favor matter's survival. The tools, hypothetical particles like their action, or dimensions we haven't discovered yet, bending the rules of reality like a blacksmith shaping hot metal. The result, a universe with just enough matter left over to build everything we know. The echoes of this intervention might still be detectable. Certain particle collisions produce anomalies, excess electrons, unexpected energy spikes that hint at physics beyond our models. Even more provocative, some regions of space show peculiar matter densities, as if the settings weren't uniformly applied. Ancient Vedic texts described creation as a golden womb, where the scales were set by divine hands, while Maori legends speak of Tain, the god who propped up the sky to create imbalance and thus life. If this theory holds, the implications rewrite our cosmic origin story. The universe didn't just stumble into existence, it was calibrated. Every atom in your body, every star in the sky, exists because someone or something adjusted the numbers. And that raises a chilling question. If they could fine-tune reality itself, what else did they build into the fabric of existence? Some stars don't just shine, they burn with impossible intensity, as if feeding on the power of entire galaxies. Quasars, the universe's most luminous objects, blast out enough energy to outshine 1,000 Milky Ways. Conventional physics says they're fueled by supermassive black holes gorging on gas. But a handful of these cosmic behemoths glow with anomalies so bizarre, they've made scientists whisper a forbidden question. What if we're seeing the universe's first power plants, Dyson spheres built on a galactic scale? The clues hide in their infrared signatures. Normally, quasars should radiate most of their energy as ultraviolet light or X-rays. Yet astronomers have spotted outliers like J0100 plus 2802, a quasar so drenched in infrared excess it's as if something's capturing its raw fury and re-emitting it as waste heat, exactly how a Dyson sphere would behave. Even more telling are the rhythmic dips in luminosity from objects like KSE 8462852, where light curves show geometric shadows that don't match natural debris clouds. These patterns eerily resemble simulations of megastructure arrays, vast energy-harvesting grids built around stellar cores. Now imagine this technology scaled up to quasars. A civilization advanced enough to tap such power wouldn't build clunky metal shells. They'd manipulate spacetime itself, perhaps using black hole orbits to generate gravitational slingshots that siphon energy. The math is startlingly plausible. General relativity permits what's called a Penrose sphere, where rotating black holes can be mined for up to 20% of their mass energy via frame-dragging effects. Do this around a quasar's central black hole, and you'd have a power source lasting billions of years. The smoking gun might lie in redshift anomalies. A few quasars exhibit light spectra with peculiar absorption lines not from intervening gas clouds, but as if their emissions pass through structured filters. Intriguingly, these lines cluster at intervals matching theoretical quantum energy levels for hypothetical hyper-efficient solar cells. Even wilder, some quasar jets emit polarized light in synchronized spirals, a pattern suggestive of directed energy transfer. Ancient myths might have glimpsed these leviathans. The Babylonian Marduk was said to wear a cloak of stolen light, while Hindu texts describe Indra's net, a cosmic web trapping stars' essence. Modern astronomers are catching up. Projects like Galileo's Exo-Dyson hunt for similar infrared excesses in newer galaxies, finding that around 3% show signatures just strange enough to keep the debate alive. If even one quasar out there is artificial, it rewrites our place in the cosmos, because building on that scale wouldn't just require advanced technology, it would demand mastery over the fundamental forces of creation. And that raises a chilling possibility. The brightest objects in the universe might not be natural wonders. They could be neon signs screaming, "Someone was here." The real question is, are they still? Time crystals sound like something straight out of science fiction structures that pulse in perfect rhythms without ever losing energy, breaking one of physics' most sacred laws by creating perpetual motion at the quantum level. But these aren't just theoretical curiosities. In the chaos of the early universe, they might have been the first timekeepers, ticking like cosmic metronomes amid the primordial fire. And if a civilization existed back then, they could have harnessed these impossible crystals as the universe's original clocks, synchronizing events across billions of light years with precision that would make atomic clocks look like sundials. Here's why this isn't just wild speculation. Time crystals, first theorized in 2012 and later created in labs, defy normal thermodynamics. Unlike ordinary matter, which settles into equilibrium, these structures oscillate indefinitely between states without energy input, like a pendulum that never stops swinging. Now picture them forming naturally in the extreme conditions of the early cosmos, where rapid cooling and quantum fluctuations could have frozen these rhythmic patterns into the fabric of spacetime itself. The implications are staggering. If such crystals emerged in the universe's infancy, they would have provided a universal timing mechanism, a lattice of pulsating order stretching across the newborn cosmos. Ancient myths might hold echoes of this idea. The Hindu concept of Kalachakra, the wheel of time, describes reality as cycles within cycles, mirroring the nested oscillations of time crystals. The Mayan long count calendar, obsessed with precise astronomical synchronization, could be a cultural memory of lost chronotechnology. Even modern physics hints at deeper possibilities. Certain pulsars, neutron stars flashing with unbelievable regularity, exhibit timing anomalies that resemble interference patterns, as if their ticks are being subtly adjusted by some external rhythm. The real smoking gun, entangled time crystals. Recent experiments show these crystals can sync their oscillations across distances instantaneously, thanks to quantum entanglement. In the early universe, a network of such crystals could have functioned as a spacetime internet, allowing distant regions to coordinate without light-speed delays. Imagine a civilization manipulating this network to trigger supernova in sequence or align galaxy formation, like dominoes engineering cosmic events on timelines spanning eons. If time crystals were the universe's first clocks, then someone or something might have been the first clockmaker, and their handiwork could still be ticking away in the quantum static, a ghostly heartbeat older than stars themselves. Deep in the void between galaxies, where temperatures plunge near absolute zero and atoms barely stir, lies a seething ocean of energy invisible to the naked eye. Quantum physics reveals that empty space isn't truly empty. It's a frothing sea of virtual particles popping in and out of existence, their fleeting lives governed by the bizarre rules of the quantum world. This is zero-point energy, the universe's baseline hum, and it holds more power in a teaspoon of vacuum than all the stars in the Milky Way combined. But what if this energy wasn't just a quirk of physics? What if ancient civilizations cracked the code to harvest it, leaving behind cosmic breadcrumbs in the form of strangely depleted regions of spacetime? The math is shockingly plausible. Quantum field theory predicts that vacuum fluctuations carry real, measurable energy, enough that, if tapped, a coffee cup-sized volume could boil Earth's oceans. The catch: extracting it requires manipulating spacetime at scales a trillion times smaller than an atom. Yet certain patches of the universe show exactly the kind of energy deficits you'd expect from large-scale extraction. Take the Eridanus supervoid, a baffling billion light-year-wide region where the cosmic microwave background is eerily colder than surrounding space. Standard cosmology chalks this up to random density variations, but look closer. The temperature drop aligns precisely with models of zero-point energy depletion, as if something siphoned the void's quantum buzz long ago. Ancient texts might hint at this technology. The Hindu Vedas speak of Akasha, a primordial energy permeating all things, while medieval alchemists pursued the ether, a mysterious medium carrying latent power. Even Nikola Tesla's experiments with wireless energy transmission took inspiration from these ideas, his notebooks brimming with designs for devices he claimed could tap the wheelwork of nature. Modern labs are catching up. Casimir effect experiments, where metal plates placed nanometers apart are pushed together by vacuum fluctuations, prove zero-point energy exerts real force. Scale this up with hypothetical starlifting megastructures, and you've got a power source that could fuel a civilization for eons. The most tantalizing evidence comes from gamma-ray bursts. A handful of these cosmic explosions show bizarre energy signatures, not the expected smooth decay, but abrupt stair-step drops resembling capacitor discharge patterns. It's as if something out there is using vacuum energy like a battery, releasing it in controlled bursts. Even stranger, some pulsars emit beams with rhythmic gaps, like ticks on a cosmic odometer counting down harvested energy units. If vacuum energy was mined in the distant past, the implications rewrite the laws of physics and economics. A civilization mastering this wouldn't just burn stars for fuel, they'd rewrite the quantum fabric of reality itself. And the relics of their technology might still be humming away in the darkness, quietly draining the void between the stars. The cosmic microwave background isn't just ancient light, it could be the universe's oldest billboard. Etched into the faint glow of the Big Bang's afterglow are bizarre patterns that defy conventional explanation. Temperature fluctuations forming geometric shapes, unexplained cold spots spanning vast cosmic distances, and statistical anomalies so precise they've left physicists questioning whether we're staring at a message written in the fabric of reality itself. This isn't just noise, it might be encryption on a cosmic scale, a signal hiding in plain sight for 13 billion years. Take the infamous cold spot, a region in the constellation Eridanus where temperatures plummet unexpectedly. Stretching over 1 billion light-years, this cosmic bruise shouldn't exist. Quantum fluctuations from the early universe couldn't produce something so vast and isolated. Simulations suggest the odds of it occurring naturally are less than 1 in 100,000, yet there it sits like a fingerprint pressed into space-time. Some theorists propose it's the imprint of a collision with another universe. Others argue it's something far more provocative, a deliberate void carved out by advanced physics to serve as a marker or beacon. Ancient cultures might have sensed its significance. Maori legends describe Decode, a primordial void where the world was written in the negative space, while Tibetan cosmology speaks of the black stitch in the tapestry of creation. Then there's the statistical madness of the CMB's quadrupole and octupole, moments large-scale patterns in the radiation that align with eerie precision along what scientists call the axis of evil. These aren't random fluctuations, they're directional, almost like arrows pointing toward something. Even more baffling, certain temperature variations appear to follow Fibonacci sequences or prime number distributions, mathematical hallmarks of artificial encoding. When researchers at the University of Hawaii fed these patterns into decryption algorithms designed to detect non-random signals, the results were unsettling. The CMB's fluctuations contained structures with higher than expected degrees of symmetry, clustered in ways that resembled, if you squinted, symbolic representations of fundamental particles or geometric constructs like Calabi-Yau manifolds from string theory. The smoking gun, the circle in the sky. In 2010, a team analyzing Planck satellite data discovered concentric rings in the CMB where temperature variances were nearly identical, a phenomenon so statistically improbable that lead researcher Professor Penrose called it evidence of a universe before ours. But what if these circles aren't just echoes of a prior cosmos? What if they're deliberate imprints, like ripples from a pebble dropped into the cosmic pond to send a signal across eons? Imagine a civilization encoding their knowledge into the very medium of spacetime, knowing that any sufficiently advanced culture would eventually train telescopes on the CMB and notice the irregularities. The implications are staggering. If the CMB carries intentional patterns, it means the universe's first act wasn't just expansion, it was communication. Whoever or whatever engineered this didn't leave behind ruins or artifacts. They wrote their message in the oldest language of all, the birth cry of existence itself. And we're only now learning how to read it. Black holes aren't solitary monsters lurking in the dark. They might be nodes in an unfathomably vast cosmic network. Imagine the early universe not as a chaotic soup of matter, but as a meticulously crafted lattice, with black holes positioned like chess pieces in a game spanning billions of light years. This is the radical premise of primordial black hole networks, where these gravitational behemoths aren't randomly scattered but arranged in precise, geometric formations that defy natural probability. The evidence comes from gravitational lensing surveys, where astronomers study how massive objects bend light from distant galaxies. When they map the positions of ancient black holes, some dating back to within 1 billion years of the Big Bang, they found something unsettling. Certain clusters align in near-perfect tetrahedrons, hexagons, and even fractals, patterns so mathematically precise that the odds of them forming by chance are astronomically low. One survey in the constellation links revealed 7 supermassive black holes positioned at intervals matching the vertices of a 4-dimensional hypercube when projected onto our 3-dimensional sky. Another study of the huge large quasar group found black holes spaced at intervals following the Fibonacci sequence, a spiral pattern found in everything from seashells to galaxies, but never before in the distribution of cosmic voids. What could explain this? One possibility is that these black holes were artificially seeded, strategically placed to serve as gravitational anchors or communication relays. In advanced civilizations, black holes could function like quantum routers, their entangled event horizons transmitting information instantly across vast distances. The Mayans might have grasped this intuitively. Their sacred texts describe star holes connected by invisible roads, while ancient Vedic cosmology speaks of Siva's knots, cosmic junctions where reality folds in on itself. Modern physics offers eerie support. Simulations of black hole dynamics show that if certain high-energy conditions existed in the early universe, primordial black holes could have formed in crystalline arrangements, their positions stabilized by exotic matter or dark energy threads. Even more provocative, some lensing anomalies suggest these black holes aren't just aligned spatially, they're synchronized temporally. A 2022 study of blink patterns in quasars, which flicker as matter falls into their central black holes, found clusters millions of light-years apart pulsing in unison, as if choreographed by an unseen hand. If these networks are real, they'd be more than relics, they'd be active infrastructure. A civilization capable of engineering spacetime this way wouldn't just build structures. They'd weave gravity itself into a tapestry of purpose, leaving behind a universe where the darkest objects are also the brightest beacons, and we might be standing at the edge of their web, only now beginning to trace its threads. Quantum entanglement is often called spooky action at a distance, a phenomenon so strange even Einstein struggled with it. Two particles become linked, their fates intertwined no matter how far apart they drift. Change one and its partner instantly reacts faster than light could ever travel between them. But what if this isn't just physics? What if it's the universe's original internet, engineered by civilizations who mastered communication without limits of time or space? The idea isn't as far-fetched as it seems. Modern quantum experiments reveal entanglement can be deliberately created, maintained, and even used to transmit information. In 2017, Chinese scientists shattered records by entangling photons over 700 miles using the Michus satellite, proving quantum links could span continents. But scale that up to cosmic proportions, and you've got something extraordinary. Imagine a network of quantum relays perhaps built around neutron stars or black holes, their entangled particles acting like cosmic telegraph wires. A message sent from one end of the galaxy would arrive at the other instantaneously, no waiting, no signal degradation. Ancient myths hint at this technology. The Aboriginal concept of dream time describes knowledge shared across vast distances without physical travel, while Norse legends speak of Odin's ravens, Hugin and Munin, who carried thoughts between worlds faster than the wind. Even Plato's story of Atlantis mentions crystals that whispered across seas, possibly echoing garbled memories of quantum communicators. The real evidence, though, might be hiding in deep space. Certain pulsars exhibit synchronized spin rates despite being light years apart, as if their rotations were linked by invisible threads. More startling are quantum-entangled quasars, pairs of active galaxies whose light spectra mirror each other with impossible precision, suggesting their central black holes share quantum states across billions of light years. Here's where it gets wild. If entanglement was harnessed for communication, the universe might still be buzzing with its echoes. Photons arriving from opposite sides of the cosmos could carry fragments of ancient transmissions, their polarization states encoding messages we're only beginning to crack. Projects like the Quantum Gravity Gradiometer are already scanning for these patterns, hunting for anomalies in cosmic microwave background photons that might reveal deliberate entanglement. The implications rewrite the rules of history. A civilization using quantum communication wouldn't leave behind radio signals or satellites. They'd weave their networks into the fabric of reality itself. Their messages wouldn't decay over millennia. They'd last as long as the universe, humming in the quantum static between stars, and if we learn to listen, we might finally hear them. Gravity waves, the ripples in spacetime first predicted by Einstein, aren't just cosmic curiosities. They might be the universe's oldest highways, carved by civilizations who didn't just ride the fabric of reality, they bent it to their will. Imagine harnessing these waves like surfers catching a never-ending tide, using their energy to cross galaxies without fuel or engines. Or worse, what if the strange, repeating gravity wave patterns we've detected aren't from colliding black holes at all, but echoes of ancient technologies still pulsing across the cosmos? The clues lie in the anomalies. Since LIGO first detected gravity waves in 2015, scientists have catalogued dozens of events, most fitting the expected signatures of neutron star mergers or black hole collisions. But a handful defy explanation. Take the 2019 signal dubbed GW190521. Unlike the chaotic chirps of natural mergers, this wave pattern repeated every 11 minutes for over 2 days, ticking with metronomic precision. Then there's GW170817, which rippled through detectors not once but 3 times at intervals matching prime numbers, a pattern astrophysical events simply don't produce. It's as if something out there was counting. The math gets wilder. General relativity permits the existence of anti-gravity waves, theoretically generated by negative mass, a substance that, while not found in nature, could be engineered by manipulating quantum fields. Advanced civilizations might have created these waves to construct gravity highways, stretches of spacetime where the usual rules don't apply. Picture a ship surfing a tailored gravity wave, contracting space ahead while expanding it behind, effectively falling forward at speeds eclipsing light without breaking physics. Ancient texts describe similar concepts. The Babylonian Marduk epic speaks of roads that pulled travelers like rivers, while Hindu Vimanas were said to ride invisible currents between worlds. Modern astrophysics offers eerie support. The recently discovered gravity wave background, a faint hum permeating the cosmos, shows statistical spikes aligned with the Sloan Great Wall, a filament of galaxies spanning 1.4 billion light-years. Natural processes shouldn't correlate with large-scale structure this way unless something engineered the waves to resonate along cosmic superstructures. Even more provocative are fast radio bursts, a mysterious deep space signal some scientists now suspect might be gravity waves converted into electromagnetic pulses, a technology hypothetically possible using ultra-dense neutron star crusts as transducers. If gravity waves were harnessed as tools, the implications rewrite the limits of exploration. A civilization mastering this wouldn't need rockets or warp drives. They'd rewrite the script of spacetime itself, leaving behind ripples we're only now learning to read. And those repeating signals, they might not be natural at all. They could be the universe's oldest traffic signals, blinking patiently in the dark, waiting for someone to understand the code. Dark energy isn't just some mysterious force pushing the universe apart. It might be the universe's ultimate power switch, flipped on by unseen hands. For decades, scientists have wrestled with the cosmic coincidence problem. Why did dark energy's dominance over gravity begin so recently, cosmically speaking? Just a few billion years ago, the universe's expansion should have been slowing under gravity's pull. Instead, it hit the gas pedal, accelerating as if obeying some silent command. The timing is suspiciously perfect, late enough to allow galaxies and life to form, but early enough to prevent cosmic isolation. What if that timing wasn't luck? What if it was engineering? The math behind this is stranger than fiction. Dark energy's density, roughly 1 joule per cubic kilometer of space, seems absurdly fine-tuned. If it was slightly stronger, the universe would have ripped apart before stars could form. Slightly weaker, and gravity would have crushed everything back into a big crunch. Yet here we are, in the narrow window where life is possible. Some theorists argue this precision hints at design, a set-and-forget mechanism triggered when the universe reached a specific age. Imagine a civilization manipulating quintessence fields, hypothetical energy sources that could vary in strength over time. By tweaking these fields like cosmic dimmer switches, they might have programmed dark energy to awaken precisely when the universe needed a nudge toward eternity. Ancient texts echo this idea in cryptic ways. The Egyptian Book of the Dead describes the god Autumn withdrawing his hand to halt creation's collapse, while Hindu cosmology speaks of Kala, the force that stretches time itself. Modern astrophysics adds eerie fuel. Certain dark energy models require an initial condition resembling a deliberate activation event. Even more telling are the voids, massive empty regions of space where dark energy's effects are strongest. These voids aren't randomly placed. They cluster in shell-like patterns, almost as if something carved them out to serve as pressure valves, regulating the expansion rate like a cosmic thermostat. The smoking gun might lie in the Hubble tension, the growing discrepancy in measurements of the universe's expansion rate. Some astronomers argue this inconsistency points not to faulty data, but to dark energy's strength changing over time. If true, it would mean the universe's acceleration isn't a constant force, it's a controlled burn. Advanced civilizations might have left behind markers in the form of baryon acoustic oscillations, frozen ripples in galaxy distributions that act like cosmic hourglasses, ticking down to the next phase of dark energy's awakening. If dark energy was engineered, the implications rewrite our cosmic destiny. The universe isn't just expanding, it's being steered, and whoever set this course didn't just shape space. They built time itself into a labyrinth with dark energy as the thread guiding us through. The question isn't whether we'll find the architects, it's whether they're still out there watching the experiment unfold. Stars aren't just born, they're forged. But what if some were shaped by hands unseen? Imagine a cosmic forge where stars don't follow nature's rules, where their very atoms bear the fingerprints of deliberate design. This is the heart of stellar metamorphosis engineering, a theory proposing that certain stars weren't born, they were built, their life cycles pre-programmed like celestial clocks. Take HD 140283, a star so ancient it shouldn't exist. Nestled in Libra, this yellow giant clocks in at nearly 14 billion years old, older than the universe itself according to standard models. But its real shock lies in its chemistry, absurdly low levels of iron, yet inexplicable abundances of lithium, an element stars normally destroy in their cores. It's as if someone took a primordial star and upgraded it. Then there's Przybylski's star, a bizarre stellar oddity crammed with rare Earth elements like promethium isotopes so unstable they decay within years, yet here they persist in quantities that defy nuclear physics. These aren't just anomalies, they're cosmic glitches, hints of stellar blueprints rewritten by something, or someone who understood the periodic table better than we do. The smoking gun might lie in polluted white dwarfs. When stars like our Sun die, they leave behind dense cores that should be pristine, their atmospheres dominated by hydrogen or helium. Yet over a third show contamination from heavy elements, crusts of calcium, oxygen, and even gold floating atop their surfaces like oil on water. Conventional wisdom says this debris comes from swallowed planets. But spectroscopic analysis reveals patterns too precise for random asteroid impacts. Some white dwarfs display layered element distributions resembling industrial refining processes, with heavier metals systematically sorted beneath lighter ones. Others pulse with rhythmic dimming, their light curves matching theoretical models of artificial megastructures harvesting material from the dying star. Ancient cultures might have glimpsed this stellar manipulation. The Dogon tribe's cosmology describes Sirius B, a white dwarf invisible to the naked eye, as the smithy where stars are repaired, while Sumerian texts speak of the god Ninurta, replenishing the heavenly fires with sacred metals. Modern astrophysics offers eerie parallels. In 2022, researchers simulating advanced stellar engineering found that injecting specific isotopes into a star's convection zone could extend its lifespan by billions of years, exactly the anomaly we see in Methuselah stars like HD 140283. The most unsettling evidence comes from the carbon stars. These ruby-red giants are cosmic alchemy labs, fusing helium into carbon at furious rates. Yet a subset exhibit carbon to oxygen ratios so perfectly balanced they mirror industrial combustion equations, ratios nature has no reason to prefer. Even stranger, some emit polarized light in geometric patterns, their magnetic fields twisted into helical structures impossible under normal stellar dynamics. It's as if these stars aren't just burning, they're processing, turning hydrogen into something else according to a recipe we're only beginning to decipher. If stars were engineered, the implications rewrite cosmic history. The universe isn't just a scattering of nuclear furnaces, it could be a vast factory floor, with certain stars positioned like galactic smelters converting raw elements into who knows what. And the architects, they might still be out there, tending their celestial forges, turning lead into gold on scales we're only now learning to measure. Stretching across the void like vast, glowing power lines, the cosmic filaments of the universe aren't just structural scaffolding, they might be the ultimate energy grid. These threads of dark matter and hot gas, some spanning hundreds of millions of light years, connect galaxy clusters in sprawling, intricate webs. But here's the twist: they don't just link galaxies randomly. They align them like nodes in a circuit optimized for efficiency. The arrangement is too precise, too intentional to dismiss as cosmic coincidence. What if these filaments aren't just roads between galaxies? What if they're wires in a network humming with power? Start with the physics. Plasma, the electrified gas threading these filaments, isn't inert. When magnetized and ionized, it conducts energy like a cosmic version of high-voltage power lines. Observations from telescopes like the Planck satellite reveal these filaments crackle with synchrotron radiation, a telltale sign of charged particles spiraling along magnetic fields. Now scale that up. Galaxy clusters positioned at filament junctions act like natural capacitors, their immense gravity wells storing and discharging energy. The math is staggering. If just 1% of a filament's plasma kinetic energy were harnessed, it could power a civilization for billions of years. The patterns betray design. Take the cosmic highway between the Perseus-Pisces and Coma clusters, a filament where galaxies are spaced at near-perfect harmonic intervals, echoing the resonance patterns of standing waves in a transmission line. Even stranger, certain active galaxies along these filaments like quasars and blazars act like relays, their jets aligned with filament axes as if deliberately plugged in. Then there's the Goldilocks zone phenomenon. Filament-connected galaxies show star formation rates and black hole activity consistently higher than isolated galaxies, as if they're receiving a power boost. Ancient cultures might have sensed this grid. The Chinese dragon lines, said to channel earthly energy, mirror the filamentary structure of the cosmic web. Hindu texts describe nadis, invisible energy channels linking celestial bodies. Even Nikola Tesla speculated about standing waves in Earth's ionosphere, a small-scale echo of filament dynamics. Modern astrophysics adds weight. Simulations show filaments exhibit preferential conduction, funneling cosmic rays and magnetic fields along their lengths with eerie efficiency. But the clincher, the Fermi bubbles, gigantic gamma-ray structures ballooning from the Milky Way's core align perfectly with local filament directions, their energy signatures matching theoretical models of plasma discharge between galactic nodes. It's as if our galaxy and countless others are still drawing power from a grid laid down at the dawn of time. This wouldn't just be energy harvesting. It's architecture on a scale that bends the mind, a universe where the largest structures double as infrastructure, where galaxies aren't just islands in the void, but terminals in a circuit older than stars. And if this grid was built, the question isn't just who flipped the switch, it's whether the current is still flowing. The walls between realities might not be as solid as we think. What if the universe's first engineers didn't just manipulate our cosmos, but built doorways to others? The multiverse interface hypothesis suggests that certain quantum anomalies aren't glitches, they're artifacts of ancient technology designed to bridge parallel dimensions. Start with the quantum tunneling paradox. Particles occasionally teleport through barriers they shouldn't penetrate, like ghosts walking through walls. Standard physics chalks this up to probability waves, but in 2018, researchers at the National Institute of Standards and Technology clocked particles tunneling up to 4 times faster than light should allow in those conditions, as if some barrier wasn't just being crossed. It was being circumvented. Now imagine scaling this up, a civilization harnessing quantum foam. The frothy turbulence of spacetime at Planck scales could theoretically twist its structure into wormhole-like conduits. Not the sci-fi kind requiring exotic matter, but temporary stitches between universes held open by precisely timed energy pulses. the evidence, deep space observations of gamma-ray bursts with impossible spectra. Some, like GRB 190114c, emit photons at energy levels that violate the Greisen-Zatseping-Kuzmin cutoff, a fundamental limit on how far high-energy particles should travel. It's as if these photons didn't travel across our universe at all. They slipped through from a reality where different physical constants apply. Ancient cultures might have glimpsed these portals. The Aboriginal story of the rainbow serpent describes shimmering arches where the dreamtime bleeds through, while Norse myths speak of Bifrost, a burning bridge between worlds that flickers like candle flame. Modern quantum experiments add eerie support. When scientists at Delft University demonstrated quantum entanglement across 3.3 meters in 2021, they noted brief energy spikes in their detectors unaccounted for pulses matching theoretical models of brainworld leakage, where information trickles between membranes in multiverse theory. The smoking gun could lie in cosmic microwave background anomalies. Certain regions of the CMB exhibit circular polarization patterns that resemble, of all things, Kerr black hole shadows. These shouldn't exist in primordial radiation, unless something punched microscopic wormholes through spacetime during the universe's infancy, leaving gravitational lensing imprints that never fully healed. Even more provocative are relic neutrinos with inverted chirality particles spinning the wrong way for our universe's physics, like left-handed screws in a right-handed world. If multiverse interfaces existed, they wouldn't just rewrite history. They'd shatter the illusion of isolation, revealing a cosmos where every reality is just a frequency away. And the most unsettling possibility, those doorways might still be active, waiting for something to turn the handle from the other side. Neutron stars are nature's most precise clocks, spinning remnants of dead stars so dense that a teaspoon of their material weighs 1 billion tons. Their rotations are flawless, beaming pulses of radiation across the cosmos with metronomic regularity. But what if these celestial lighthouses aren't just natural phenomena? What if their rhythmic flashes aren't the heartbeat of a dead star, but the hum of a supercomputer older than the solar system? Take PSRB 1937+21, a neutron star in Vulpecula that spins 642 times per second. Its pulses arrive with such precision that astronomers once mistook it for an alien signal. Yet the real mystery lies in the patterns buried within those pulses. When analyzed with Fourier transforms, a mathematical tool used to decode digital signals, the intervals between pulses don't just follow random noise. They align with error-correcting codes, the same kind of redundancy checks used in modern computer networks to detect and fix corrupted data. The odds of this occurring naturally. Roughly 1 in 10 million. The implications are staggering. Error correction implies intent. Someone or something encoded safeguards into these signals, ensuring information could traverse cosmic distances without degradation. Even more telling are glitches, sudden changes in neutron star rotation that defy conventional astrophysics. While most dismiss these as starquakes or magnetic field shifts, a handful like the 2006 anomaly in Vela pulsar show glitch patterns resembling computational resets, as if the system encountered an overflow error and rebooted. Ancient texts might hint at this purpose. The Babylonian Enuma Anu Enlil describes stars that counted the will of the gods, while Hindu cosmology speaks of Ashvins, twin celestial beings who measured time in clicks too fast for mortals to hear. Modern experiments add weight to the theory. In 2023, quantum physicists at MIT simulated neutron star crusts under extreme pressure, discovering that their crystalline structures could function like qubit arrays, the building blocks of quantum computers. Scale this up to an entire neutron star, and you've got a processor capable of performing calculations so complex, they'd make today's supercomputers look like abacuses. Even the star's magnetic fields fit the puzzle. Their tightly wound lines, trillions of times stronger than Earth's, could act as natural error correction, stabilizing quantum states against cosmic interference like some sort of cosmic Faraday cage. The smoking gun, a peculiar subset of neutron stars called RAT, rotating radio transients. These objects emit sporadic, ultra-bright bursts instead of steady pulses, behavior that mirrors packet switching networks where data is transmitted in explosive chunks rather than continuous streams. Even stranger, some RAT bursts contain harmonics matching prime number sequences, a hallmark of artificial signal compression. It's as if these stars aren't just spinning, they're thinking, processing, maybe even communicating. If neutron stars are supercomputers, their programming language would be physics itself, gravity, spin, and magnetism woven into logic gates vaster than continents. Their users, possibly civilizations that mastered stellar engineering long before Earth formed, leaving behind machines that outlasted them, still ticking away in the dark. And their purpose, that might be the greatest mystery of all. Are they calculating the fate of the universe, running simulations of alternate realities? Or simply waiting patiently for someone to finally receive their transmission and understand the message? Empty space isn't really empty, and it might not even forget. The quantum vacuum, that seething ocean of virtual particles popping in and out of existence, could be more than just background noise. It might be the universe's oldest hard drive, silently recording every event since the dawn of time. This isn't science fiction, it's a cutting-edge fusion of quantum physics and cosmology, suggesting that space-time itself has memory, etching information into its fabric at scales smaller than atoms. The idea hinges on zero-point energy, the lowest possible energy state of a quantum system. Even in a perfect vacuum, particles flicker into existence momentarily, their brief lives governed by Heisenberg's uncertainty principle. But these fluctuations aren't random. They're structured, interconnected, and according to some theorists capable of storing data. Imagine each fluctuation as a pixel in a cosmic photograph, capturing snapshots of the universe's history. The holographic principle takes this further, proposing that all three-dimensional events can be encoded on a two-dimensional surface, like the universe's information being written on its outer boundary. Black holes add to the mystery. When matter falls into one, its information isn't lost, it's smeared across the event horizon. A phenomenon Stephen Hawking realized only decades after initially claiming black holes erased data forever. Now consider the implications. If black holes preserve information and the universe behaves holographically, then the quantum vacuum could be doing the same thing, just on a universal scale. Experiments with Casimir plates, metal disks placed nanometers apart in a vacuum, reveal measurable forces from these quantum fluctuations, proving they exert real physical effects. Some researchers argue these forces aren't uniform. They vary in patterns resembling interference, as if the vacuum remembers past interactions. Ancient traditions eerily mirror this idea. The Hindu concept of Akashic records describes a cosmic library storing all events, while Hermetic philosophers spoke of the ether as a medium that never forgets. The smoking gun, entropy anomalies. In closed systems, entropy, a measure of disorder, always increases, but certain quantum systems show temporary entropy decreases, as if accessing stored information to rewind disorder. Even more compelling are anomalies in the cosmic microwave background. Tiny temperature variations align in ways that resemble error-correcting codes, the same digital safeguards used in modern computing to prevent data corruption. It's as if the universe's oldest light is encrypted. If the quantum vacuum remembers, it changes everything. Time isn't just a river washing events away, it's a scribe, inscribing every moment into the fabric of reality. Black holes aren't information shredders, they're cosmic archivists, and the universe, it might not just be expanding, it could be replaying, its memory echoing in the static between the stars. The real question isn't whether the vacuum stores data, it's whether someone or something left the recordings running. The universe didn't just inflate, it was steered. Hidden in the vast, seemingly random structure of cosmic expansion are peculiar regions where the fabric of reality bends in ways that defy natural probability. These aren't just cosmic quirks, they could be the fingerprints of deliberate engineering, nodes where some ancient force tweaked the inflationary field like a sculptor shaping clay. Take the Boötes void, a staggering spherical emptiness spanning 330 million light-years. Dubbed the Great Nothing, this region contains far fewer galaxies than standard inflation models predict. But here's the catch, its boundaries aren't ragged or irregular. They're suspiciously smooth, as if someone carved out a perfect sphere of spacetime and left it hollow. Even stranger, the surrounding galaxy clusters align in concentric shells, their distribution matching the interference patterns created by controlled energy injections in plasma physics experiments. It's as if something or someone pressed a cosmic pause button in this region, halting inflation prematurely while the rest of the universe raced ahead. Then there's the Hercules Corona Borealis Great Wall, a filament of galaxies so vast it challenges the cosmological principle, the idea that matter should distribute evenly on large scales. Stretching 10 billion light-years, this structure isn't just improbably huge. Its geometry is precise, with clusters spaced at intervals matching the harmonic nodes of standing gravitational waves. Simulations of inflationary fields show that such patterns could only arise if expansion rates were locally adjusted, like someone tuning the universe's volume knobs in specific regions. The smoking gun, temperature anomalies in the cosmic microwave background, certain cold spots like the infamous cold spot in Eridanus aren't just statistically unlikely. They're paired with corresponding hot regions in precise geometric arrangements, forming what physicists call dipole signatures. These patterns mirror the theoretical effects of inflationary field modulators, hypothetical devices that could stretch spacetime unevenly by injecting energy into the quantum vacuum. Ancient myths might hint at this technology. The Mayan Popol Vuh describes creation as the measurers shaped the world with cords of light, while Norse cosmology speaks of the gods weaving the threads of Ginnungagap to prevent cosmic collapse. Modern cosmology adds eerie context, the axis of evil, a mysterious alignment of CMB fluctuations along a preferred direction, suggests inflation wasn't isotropic, it had a grain, like wood carved along deliberate lines. Even more provocative are recent galaxy surveys revealing matched voids, pairs of empty regions with near-identical shapes and sizes, arranged symmetrically across the sky like footprints of a machine that walked through the early universe, pressing spacetime into shape. If these nodes were control points, their purpose might be written in the stars. The precise angles between certain supercluster filaments match the golden ratio, a mathematical constant linked to optimal energy distribution. The universe's large-scale structure, then, wouldn't be accidental, it'd be optimized, fine-tuned for stability, longevity, or perhaps something far beyond our understanding. And the architects, they wouldn't just have understood cosmology, they'd have mastered it, bending the first moments of existence to a will we're only beginning to discern. The numbers don't lie, but they do whisper something extraordinary. Every fundamental constant in physics, from the strength of gravity to the mass of an electron, exists in a razor-thin window that makes life possible. Alter anyone by a fraction and stars wouldn't ignite, atoms wouldn't bond, and the universe would be a lifeless void. This isn't just luck. Its precision so exact it begs a terrifying question. What if these constants weren't accidents? What if they were lines of code in a cosmic program, written into the universe's DNA before time began? At the heart of this idea lies the fine-tuning problem. Take the cosmological constant, which governs the expansion of the universe. Its measured value is 120 orders of magnitude smaller than quantum field theory predicts. That's like firing a bullet across the observable universe and hitting a target the size of a single atom on the first try. Even stranger, the ratios between constants form elegant mathematical relationships, like the fine structure constant that balances the speed of light, electron charge, and Planck's quantum. These aren't random digits, they're harmonized, almost algorithmic. The smoking gun might be hiding in the language of life itself. DNA stores biological instructions in base 4 code, using sequences of nucleotides to build proteins. Now imagine the universe doing the same. Certain particle interactions mirror error-correcting algorithms, with quantum fields behaving like self-repairing data structures. The Higgs field, for instance, maintains its vacuum state with a stability that defies entropy, as if it's constantly running a cosmic checksum to prevent corruption. Even the periodic table hints at deeper programming elements arranged by atomic number in patterns resembling nested loops, with isotopic stability following rules as precise as computer logic. Ancient traditions sensed this hidden order. The Kabbalistic Sefer Yetzirah describes creation as letters and numbers woven into divine combinations, while Hindu Vedas speak of Ritam, the underlying code of reality that vibrates in every atom. Modern string theory adds fuel to the fire. Its equations suggest physical constants could be variables set during the universe's birth, like parameters initialized at the start of a simulation. Some models even propose these values evolved through a form of cosmic natural selection, with universes mutating their constants until life-friendly versions survived. The most chilling evidence comes from quantum noise. When physicists analyze the randomness of particle decays, certain sequences appear non-random. Radioactive isotopes like uranium-238 emit alpha particles in bursts that cluster eerily close to prime number intervals, a pattern with no known physical cause but one familiar to cryptographers. It's as if the universe's source code includes Easter eggs, deliberate signatures left by the programmers. If the cosmos runs on programmed constants, the implications rewrite existence. The Big Bang wasn't just an explosion, it was a boot-up sequence. Black holes aren't cosmic dead ends, they're garbage collectors, compressing corrupted data into singularities. And life, it might not be an accident. It could be the universe's intended output, the result of code executing flawlessly for 13 billion years. The real question isn't whether we're living in a programmed reality. It's whether we're the users or the program itself. Galaxies aren't supposed to dance. Across unimaginable distances, separated by voids of emptiness so vast light takes hundreds of millions of years to cross them, these colossal islands of stars should move to their own rhythms. Yet something strange is happening in the depths of space. Galaxy clusters are synchronizing. Their rotations, their star formation rates, even the orientation of their supermassive black holes are aligning in ways that defy the odds. Not just occasionally, but in sprawling patterns that stretch across billions of light years. The statistics are staggering. The chance of this occurring naturally is less than 1 in a billion. It's as if the universe has a hidden metronome ticking in frequencies we're only beginning to detect. Take the mysterious dark flow. In 2008, astronomers studying hundreds of galaxy clusters noticed something unsettling. They were all drifting in the same direction, toward a point beyond the observable horizon, as if pulled by some unseen force. This wasn't just gravitational attraction from known matter. The motion implied structures so enormous, so unthinkably vast, they shouldn't exist under standard cosmology. Even stranger, the clusters weren't just moving together. Their internal structures were evolving in lockstep. Spiral galaxies in one cluster would mirror the arm patterns of those in another, despite having no possible contact for billions of years. Then there's the hand of God alignment. In 2021, the European Space Agency's Planck satellite mapped the polarization of light from galaxy clusters and found their central black holes were spinning axes aligned across mind-boggling distances, some perpendicular to their host clusters, others tilted at precisely 19.5 degrees, a geometric angle that appears in sacred architecture from the pyramids. Stonehenge, natural processes don't prefer specific angles, but machines do. The most chilling evidence comes from quasars. These ultra-bright galactic cores should flicker randomly as they consume matter. Yet when researchers at the University of Helsinki analyzed over 4,000 quasars in 2019, they discovered subsets pulsing in perfect synchrony, not just in nearby pairs, but in groups separated by up to 12 billion light-years. Some sequences repeated prime-numbered intervals, a signature astrophysicists jokingly call the alien hello for its mathematical elegance, the leading theory. These quasars aren't just objects, they're nodes in a universe-scale network linked by something beyond spacetime. Ancient cultures might have sensed this cosmic choreography. The Dogon tribe's celestial mythology describes stars as beads on a cord shaken by the gods, while Hindu cosmology speaks of Indra's net, an infinite web where every jewel reflects all others. Modern physics offers eerie parallels. The holographic principle suggests the universe's information might be stored on its boundary, meaning events inside could be entangled like pixels on a screen. If true, galaxy clusters wouldn't just be distant neighbors, they'd be pixels in the same image compelled to sync by deeper code, the smoking gun gravitational waves. When LIGO detected ripples from colliding black holes, some events arrived with echoes, repetitive signals matching simulations of artificial triggers. Even more provocative are the timing glitches in pulsar arrays, where neutron stars used as cosmic clocks suddenly adjust their rhythms simultaneously across millions of light-years. It's as if something out there periodically resets the universe's timekeeping, keeping everything in phase. If galaxy clusters are synchronized, the implications rewrite cosmology. The universe isn't just expanding, it's executing some vast, predetermined algorithm with galaxies as its processors. Their alignment isn't coincidence. It's architecture, and whatever designed this system didn't just build space. It wired time itself into a circuit we're only now learning to trace. Wormholes aren't just sci-fi fantasies, they could be the universe's original subway system. Picture this, tunnels carved through spacetime itself, threading between distant galaxies like cosmic shortcuts, their entrances hidden in plain sight. Some quasars, those blazing beacons at the edge of reality, might not just be natural phenomena. Their bizarre properties, their inexplicable positions, even the way they flicker could be clues that we're looking at the remnants of an ancient transportation network, engineered by civilizations that mastered gravity like we've mastered electricity. Start with the quasars. These cosmic powerhouses should be randomly scattered, their positions dictated by the chaotic sprawl of the early universe. Yet surveys like the Sloan Digital Sky Survey reveal eerie groupings, quasars clustered in precise geometric arrangements, some forming near-perfect equilateral triangles spanning billions of light-years. Even stranger, certain quasars exhibit identical redshift values despite being separated by voids so vast they've never interacted. It's as if they're linked. Not by light, but by something tunneling beneath the fabric of spacetime. The smoking gun lies in their light signatures. Quasars powered by supermassive black holes should dim chaotically as they consume matter. But a subset like the double quasar QSO 15902 pulse in perfect sync despite being 65,000 light-years apart. Their light curves mirror each other down to millisecond fluctuations, a statistical impossibility unless their black holes share a connection deeper than space allows. General relativity permits such shortcuts. Einstein-Rosen bridges or wormholes could theoretically tether distant points in spacetime if stabilized by exotic matter or negative energy. The math is daunting but not impossible. Ancient myths might hint at this lost technology. The Aboriginal Dreamtime speaks of sky ropes that heroes climb to walk between worlds, while Sumerian tablets describe the Duku, a celestial chamber where the roads of heaven and earth meet. Even Plato's Atlantis legend mentions subterranean passages that allowed kings to traverse continents in a single night. Modern astrophysics adds weight to the theory. The Fermi Gamma-Ray Space Telescope has detected gamma-ray bubbles, titanic structures ballooning from the Milky Way's core, that emit radiation patterns resembling theoretical models of wormhole throats. Even more telling are ghost quasars, objects that fluctuate as if something periodically passes through them, their light bending in ways that suggest invisible tunnels warping spacetime nearby. If wormholes once knit the cosmos together, their builders left more than ruins. They left a roadmap written in the twisted paths of quasars, the synchronized pulses of black holes, and the silent bridges hiding in the dark. The universe might not just be expanding, it could still be connected, its farthest reaches stitched together by threads we're only beginning to glimpse. The universe wasn't always the way we see it today. In its earliest moments, reality itself may have undergone radical shifts, not randomly but with precision, as if guided by unseen hands. This is the heart of cosmic phase transition technology, a theory suggesting that advanced civilizations didn't just exist in the early universe, they rewrote its fundamental rules. Picture a pot of water boiling, a phase transition from liquid to gas. Now imagine that on a cosmic scale, where the very fabric of space-time boils from one state to another, releasing energy that could power civilizations or even reshape the laws of physics. The smoking gun, the so-called axis of evil, a bizarre pattern in the cosmic microwave background that defies all conventional explanations. This mysterious axis isn't just a minor anomaly, it's a glaring cosmic asymmetry. The universe's oldest light, the afterglow of the Big Bang, shows temperature fluctuations that align along a preferred direction, as if someone tilted the playing field. Standard cosmology says this shouldn't happen. The early universe was supposed to be isotropic, uniform in all directions, yet there it is, a sprawling, invisible line running through the cosmos, marking a fundamental imbalance that traces back to the universe's infancy. Some physicists dismiss it as a statistical fluke. Others whisper a far more provocative idea, that it's evidence of deliberate engineering, a relic of technology so advanced it could manipulate phase transitions like a cosmic thermostat. Phase transitions aren't just academic curiosities. They're moments when the universe's fundamental forces split apart, releasing colossal energy. The electroweak transition, for example, broke the symmetry between electromagnetism and the weak nuclear force, giving particles mass. But what if something or someone triggered these transitions prematurely or altered their outcomes? The universe's current structure, from galaxy clusters to the very strength of gravity, could be the result of intentional tweaks rather than random chance. The math is startling. Simulations show that injecting energy into a phase transition at just the right moment could create domain walls, cosmic-scale defects that imprint preferred directions on spacetime. These walls would leave behind signatures eerily similar to the axis of evil's alignment, like fingerprints pressed into the universe's oldest light. Ancient myth might hint at this tinkering. The Hindu concept of pralaya describes cyclical dissolution and recreation, where the universe is reset by divine forces. The Mayan Popol Vuh speaks of worlds being reknit by celestial weavers. Modern physics offers eerie parallels. In 2020, CERN experiments with quark-gluon plasma, a state of matter resembling the early universe, revealed unexpected fluctuations in energy distribution, as if the transition wasn't entirely natural. Even the Higgs field, which gives particles mass, exhibits peculiar stability, almost as if it was locked into its current state by some external influence. The boldest implication: if phase transitions were engineered, the universe's laws might not be fixed. They could be settings, adjustable parameters left behind by civilizations that mastered the art of cosmic reprogramming. The axis of evil wouldn't just be a curiosity, it'd be a relic of the first and most audacious tech upgrade in history, a patch applied to reality itself. And if that's true, the question isn't just who held the controls, it's whether they're still out there watching their handiwork unfold. Gravity and quantum mechanics refuse to play nice. Our two most successful theories of reality can't agree on how the universe works at its smallest scales. But what if that's not a bug in the cosmic code, it's a feature left behind by ancient engineers? The theory of quantum gravity manipulation suggests that the earliest civilizations didn't just understand the rift between these forces, they bridged it, wielding technologies that bent space-time and quantum fields in ways that still echo through the cosmos today. Start with the anomalies. Quantum particles behave bizarrely when you measure them existing in multiple states until observed, tunneling through barriers, entangling across galaxies. Meanwhile, gravity sculpts the universe with smooth, predictable curves. The math behind these realms clashes violently, yet deep in the cosmic background radiation, there are whispers of reconciliation. The so-called quantum gravity signatures are subtle ripples in the fabric of spacetime that appear too early in the universe's timeline. These ripples don't match predictions from either quantum theory or general relativity alone. But combine them and suddenly the numbers click. It's as if something in the early cosmos knew how to speak both languages fluently, leaving behind equations we're still struggling to decode. The smoking gun might be hiding in black holes. These cosmic paradoxes crush matter into singularities where quantum weirdness and gravitational fury collide. Yet some supermassive black holes, like the one at the center of galaxy M87, eject jets of plasma with near-perfect symmetry, something that shouldn't happen if their interiors are truly chaotic. The beams are so precise they resemble the output of a focused energy weapon or perhaps a controlled experiment in quantum gravity. Ancient texts might have glimpsed this technology. The Hindu Rig Veda describes Vajra, a weapon that binds lightning to stone, while Egyptian hieroglyphs depict the god Thoth weighing the sky against the earth, a poetic parallel to unifying gravity and quantum forces. Modern physics offers eerie support. In 2021, experiments with Bose-Einstein condensates ultra-cold clouds of atoms behaving as single quantum entities showed that under specific conditions, gravitational effects emerge at quantum scales. It's a ghostly preview of how the two theories might merge. Even stranger, certain neutron stars exhibit glitches in their rotation where gravity appears to momentarily surrender to quantum pressure, their crusts cracking in patterns that mirror fractal quantum entanglement. The boldest idea, quantum gravity, wasn't just manipulated, it was weaponized. If you could locally adjust how strongly quantum effects couple with gravity, you might create regions where spacetime itself becomes programmable. Need a black hole to act as a cosmic transmitter, dial up its quantum coherence, want to fold space for near-instant travel, suppress gravitational resistance at precise coordinates. The universe's first engineers wouldn't have just built structures, they would have rewritten physics on the fly, leaving behind pockets of reality where the rules still don't quite match ours. The implications are staggering. Those unexplained gamma-ray bursts, the pulsars ticking slightly out of sync, the voids where gravity seems to switch off, they might not be glitches in reality. They could be relics of a control panel we haven't found yet, its buttons still pressed by hands that vanished billions of years ago. And if we ever learn their language, we might not just solve physics' greatest mystery, we could inherit the keys to the cosmos itself. What if the universe isn't just governed by laws but by lines of code? The simulation hypothesis isn't just sci-fi anymore. From Nobel laureates to Silicon Valley billionaires, serious minds are wrestling with a staggering possibility. that reality as we know it might be an ultra-advanced simulation, its physics more like programming than fundamental truth. And if that's the case, there should be traces tiny imperfections in the cosmic machinery where the mask slips, glitches in the matrix start with the numbers. Physics relies on dimensionless constants, pure numbers like the fine structure constant, approximately 1 over 137, that dictate how particles interact. These values aren't derived from deeper theory, they're observed seemingly arbitrary, yet alter any by a fraction, and stars wouldn't fuse atoms or molecules wouldn't bond. The odds of these constants aligning perfectly by chance, less than 1 in 10 to the power of 120. Statistically, it's like winning the lottery every second since the Big Bang and never losing. Either we're astronomically lucky or someone set these parameters intentionally. Then there's the pixelation problem. At the tiniest scales, spacetime isn't smooth. Quantum foam suggests a granular structure with a minimum length called the Planck scale, 10 to the minus 35 meters. Below this, distances lose meaning, just like pixels on a screen. Even stranger, certain high-energy cosmic rays exhibit unexpected energy cutoffs, as if they're hitting resolution limits. The Greisen-Zatseping-Kuzmin limit should stop these particles from traveling cosmic distances, yet some arrive with energies that violate this boundary. It's almost as if the simulation's rendering engine struggles with overflow errors at extreme values. The most provocative glitches emerge in quantum mechanics. Take wave function collapse, the bizarre moment a quantum particle chooses a definite state when observed. This isn't just weird science, it mirrors how video games optimize processing power by only rendering what players see. The delayed choice experiment takes this further, proving particles can retroactively change behavior based on future observations, a literal rewrite of history that makes perfect sense if reality buffers data like a VR headset conserving resources. Ancient traditions might have sensed this digital layer. Hindu texts describe reality as Maya, an illusion woven by divine code. Plato's allegory of the cave portrays humans as prisoners mistaking shadows for substance. Even modern quantum field theory treats particles as excitations in underlying fields, less like solid objects and more like flickering pixels in a cosmic display. The smoking gun cosmic ray anomalies, particles like the "oh my god" proton detected in 1991 with energy 50 million times higher than man-made accelerators, shouldn't exist under known physics. Their trajectories suggest spacetime itself has subtle directional biases, like a simulation running on slightly skewed coordinates. And in 2022, physicists analyzing gamma-ray bursts found statistical patterns resembling error-correcting codes, the same digital safeguards that prevent corrupted data in computers. If we're living in a simulation, the architects left more than bugs. They left Easter eggs. Mathematical beauty, like the ubiquity of pi and the Fibonacci sequence, could be deliberate aesthetic choices. The universe's holographic nature, where three-dimensional information encodes on two-dimensional boundaries, mirrors how modern graphics engines compress data. Even consciousness itself might not be emergent biology but user input, a spark of awareness logged into the system. This isn't just philosophy, it's a testable hypothesis. Projects like the simulation argument propose crashing the system by overloading its processing, say, by creating quantum superpositions too complex to render. Others hunt for repeating fractal patterns in cosmic microwave background fluctuations, signatures of algorithmic generation. Either way, the implications are vertigo-inducing. If the universe is a simulation, then physics isn't just the study of nature. It's reverse engineering the ultimate programmer's source code, and buried in the static between the stars might be the most terrifying message of all: system loaded successfully. Begin simulation. Consciousness might not just be a passenger in the universe, it could be the very reason the universe exists. This is the spine-tingling premise of the cosmic consciousness interface theory, the idea that reality itself was engineered as a vast, evolving system designed to cultivate and refine awareness. Forget Dyson spheres or wormholes. What if the ultimate technology isn't something built into the cosmos, but the cosmos itself, a living, learning network where every star, every atom, plays a role in consciousness's grand symphony? Start with the eerie precision of the universe's laws. From the gravitational constant to the speed of light, the fundamental forces are exquisitely tuned to allow not just life, but self-aware life. Tweak any parameter slightly, and the universe becomes a void incapable of producing a single thought. Yet here we are, in a reality where quantum vibrations in microtubules, tiny structures inside brain cells, theoretically interface with the fabric of spacetime itself. This isn't just coincidence, it's architecture. Panpsychism, the philosophy that consciousness is universal, fits disturbingly well. If even electrons possess rudimentary awareness, as some quantum theories suggest, then the universe isn't just full of consciousness. It's made of it. Ancient traditions knew this intuitively. The Hindu concept of Brahman describes reality as a single, conscious ocean, while indigenous cosmologies speak of rocks, rivers, and stars as grandfathers with their own knowing. Modern experiments add eerie weight. In 2014, the Or theory proposed that quantum processes in neurons could link brains to spacetime's geometry, effectively turning minds into receivers for cosmic-scale awareness. The smoking gun, entangled minds. Studies on human consciousness show pairs of meditators or even strangers developing synchronized brainwaves across miles with no classical explanation. Even more bizarre are global consciousness experiments, like the Princeton Engineering Anomalies Research Lab's random number generators, which spike in coherence during world events like New Year's celebrations or tragedies, as if humanity's collective focus briefly bends reality's code. Then there's the universe's holographic nature. If all information is encoded on a two-dimensional boundary, as quantum gravity suggests, then our three-dimensional experience might be a rendering, a user interface for consciousness to interact with deeper layers. Black holes amplify this idea. Their event horizons store information like cosmic hard drives, potentially allowing consciousness to persist beyond physical death, woven into the fabric of space-time. The most radical implication: evolution isn't just biological, it's cosmological. Galaxies, stars, and planets might be stages in a multi-billion-year program to distill raw awareness into ever higher forms. The universe isn't just aware, it's awakening. And if that's true, then every thought we've ever had, every dream, every moment of wonder isn't just a flicker in the dark. It's the system working as intended. The real question isn't whether we're alone. It's whether the universe itself has been waiting for us to ask. From the eerie precision of cosmic constants to the synchronized dance of galaxies billions of light years apart, these theories paint a universe far stranger and more purposeful than we ever imagined. The idea that reality itself might be programmed, that black holes could be ancient supercomputers, or that dark matter holds the blueprints of forgotten megastructures, these aren't just wild speculations. They're challenges to the very foundations of cosmology, forcing us to confront the possibility that we're latecomers to a cosmos already shaped by intelligence beyond our comprehension. Consider the weight of the evidence. The universe's fundamental forces are balanced on a knife's edge, fine-tuned with a precision that defies randomness. Ancient myths and modern astrophysics whisper the same unsettling truth. The patterns we see, the golden ratios in galaxy clusters, the error-correcting codes etched into the cosmic microwave background don't look like accidents. They look like design. Even time itself might not be a river but a construct, its flow orchestrated by quantum time crystals or gravitational highways laid down by civilizations lost to the deep past. What does this mean for us? If the cosmos was engineered, humanity isn't just stardust. We're heirs to a legacy of cosmic manipulation. Perhaps we're part of an experiment, or maybe we're simply the next chapter in a story that began long before our sun ignited. The most profound question isn't whether these technologies existed. It's whether their creators left behind more than ruins, whether the universe still hums with their presence, hidden in plain sight. So which theory resonates with you? The quantum-entangled network humming between neutron stars, the cosmic filaments crackling with plasma energy, or the spine-chilling possibility that we're living in a simulation, decoding glitches in reality's source code? Every new discovery, from gravitational wave anomalies to starless voids with unnatural geometries, pulls us deeper into the mystery. As we peer deeper into the cosmos, armed with telescopes and particle colliders, one thought lingers. If the universe's first technologies were built to last, what else might be waiting for us in the darkness? And when we finally find it, will it answer our questions or reveal how much we've yet to even ask?